So knowing that K is only good for one temperature and only good for one reaction, it's probably not surprising to learn that the units of K, and yes, K does have units, they will be different depending on the reaction. So let's take a look at a very simple example. What if we looked at rate equals K times the concentration of A? And we need to try and figure out the units with respect to K. Okay, well, rate is pretty easy. It's a change in molarity over a change in time. And square brackets always imply molarity. So we need to try and figure out a unit to plug in here for K to keep both sides of my expression equal. Now you might see already that these two terms of molarity are going to cancel each other out on either side of the equation. So what that essentially leaves me with is 1 over time. So in this case, my unit for K is going to be 1 over time. Now remember, this is a first order reaction. So for all first order reactions, the unit on K is going to be 1 over time. Let's take a look at another one. What if our overall reaction was rate equals K times the concentration of A times the concentration of B? Well, then this reaction would in fact be second order overall. Because again, we would need to add together the exponents. We don't write the exponent of 1 because that's redundant, but they would still add together to make an overall order of second order. Well, let's go through these units again. Rate is always going to be a change in molarity over a change in time. And again, my concentration of A is going to be a molarity. My concentration of B is going to be a molarity. So I need a unit of K, I wrote B by accident, I meant to write molarity. I need a unit of K that will keep both sides of this equation balanced. Again, you might see that one of these molarities is going to cancel out on either side. So I need somehow a unit on K that gets rid of this molarity on this side and adds in time as well. The only acceptable unit is going to be 1 over time, of course, but it's also going to be divided by molarity, because that way this molarity and this molarity can actually cancel out, and that introduces time on either side. So for all second order reactions, your unit on K is going to be 1 over molarity times time. Now, if we kept doing these over and over again, we would develop a pattern, but I will tell you that there is a pretty easy formula for figuring out what the overall unit on your K will be, no matter what the reaction. Now that formula is that the unit of K will always be 1 over molarity to the n minus 1 times time, where n is the overall order of the reaction. And if you want to see this in action, let's try one out. So how about rate equals K times A squared times B? So the overall order of this reaction is third order. So now before we even put our normal stuff to work here, let's plug this in and see if we can get it to work. So this would be 1 over molarity to the order minus 1. So it would be molarity to the 3 minus 1. That's molarity squared. 1 over molarity squared times time. And let's just see mathematically if that actually works out. So again, molarity over time is my rate, equals my unit of K. And this would be molarity times molarity. That would be molarity squared. times yet another molarity for the B. So only one of those molarities cancels out. I need to introduce the time to bring that back over to this side. And I still have two more molarities that I need to cancel out. So I'm going to put it over molarity squared, and it works. So this little equation right here is really good for finding the units of K pretty consistently. And I really do want you to commit this one to memory because the units of K tend to pop up with frequency on the AP exam.